All right, this is video 2 on standard form of linear equations. So let's talk back what we had before. Remember, we've been saying that the equation of a line is y equals mx plus b. Okay, this is an equation of a line. And this particular equation is something that we call slope intercept form. Okay? This word form kind of gives us a hint that perhaps this is not the only equation of a line that we could use. Right? When you have different forms of something, it's the same thing, but it's being portrayed to you in multiple ways. So standard form, what we're going to talk about in this video, it's just another way to write an equation of a line. Okay, so if standard form is another way, it is the same in many senses as y equals mx plus b. It's telling us the same information, and we can go back and forth between these forms, okay? So it's just another way we could write it. The standard form of a line is ax plus by equals c. Okay? A, b, and c are all going to be integers. Okay? What's an integer? Do we remember? Let's think back, use our vocabulary. An integer is a whole number. Okay, they're going to be whole numbers, so it's going to be a 1, 2, 5, anything that's a whole number. Could I have, let's say, 1/2? Could it be 1/2 x plus something y equals c? Okay, it couldn't, because 1/2 is not a whole number. All right, so we have ax plus by equals c. A, b, and c are integers. X and y are just variables, okay? And we could plug into them, perhaps, in ordered pair. Okay, we could put in numbers from an ordered pair where we have an x and a y, and that would work, and it would make sense. Okay, so how do we go back and forth between these two formulas that we have? Okay, if we have fractions, this is really big, we have to get rid of them, because remember we said over here that our numbers are going to be whole numbers. Okay, so we need to get rid of them. To get rid of a fraction, we need to multiply by, you guys remember the LCM, or the least common multiple? I'm going to write that in case we forget what it means. The least common multiple. And we'll talk about that a little bit more when we do our practice problems. But the least common multiple is the smallest number that goes into each of the denominators, okay? So we're trying to get rid of a fraction. We'll talk. All right? After we get rid of our fractions and we make them all whole numbers, we need to get all of the numbers, okay? All of the numbers alone on one side of the fraction. Before we had y equals, remember, and y was alone. Now we need all of the numbers alone and get all of our variables on the other side. Is it okay if our variables have coefficients, which is numbers, in front of them? Yes, remember? These a and b, those are coefficients. Those are numbers, okay? We need numbers that aren't attached to variables on the other side. So let's try a practice one. We have y equals 1/2 x minus 3. Okay? Our fraction here is 1/2. We need to find a number So it's going to have to be at least 2, or maybe a number that is greater than 2, okay? So it's going to have to be greater than 2 to get rid of this, okay? Can we just use the number 2? Do we have another fraction we're looking at? No, I don't think we do, okay? We just have the 1/2. So to get rid of that, I need to multiply this entire equation by 2. Remember, when we distribute here, this 2 is going to be multiplied by every part of my equation. So when I distribute, I'm going to get 2y equals, well, what's 1/2 times 2? Don't my 2's cancel, and I'm just left with 1? Okay, so I can say 1x, that's okay. Or I could just write x. And what's 2 times -3? Good, 2 times 3 is 6, and since it's negative, it'll be -6. Okay, so step 1, done. We've gotten rid of all of our fractions, okay? Now we need to get anything that's a number without a variable alone onto one side of the equation. Remember, get all of our numbers alone. Well, is 2y just a number, or is there a variable? This one has a variable. What about 1x? Is that a number or a variable? It's got a variable. What about -6? -6 is a number. So if we want -6 to be alone, we need to move 1x. If it's being added here, how do we get it to the other side? Subtract 1x, okay, from both sides. Now this is something we had a little bit of trouble with. Can I combine 1x with my 2y? Can those two go together? Is an x the same as a y? No. So when I simplify, it's just going to say -1x plus 2y, because my 2y is positive, equals, well, my +1 and -1 cancel, and I'm left with -6. Okay, this is written in the proper format. We can use that. All right, our next one, I'm just going to erase what we have here. And we'll move this one up so we can see it a little better. It says y equals 7/2 x plus 1/4. All right, let's go back and look at our steps. If there are fractions, do we see fractions? Ugh, I know, they're terrible. All right, this fraction has a denominator of 2, and this fraction has a denominator of 4. Okay, which number is bigger, 2 or 4? 4 is bigger. You're always going to pick the bigger number. And maybe we should write that up here. Always use the biggest denominator. Okay, so if our denominator of 4 is bigger, we're going to use the number 4. All right, I'm going to erase this so we can see our work. That means to get rid of the fractions, we need to multiply this entire equation by 4. Okay, so what's 4 times y? Good, 4y equals, all right, this one's going to be a little tricky. We'll write it so we can see it. I'm going to write 4 as 4 over 1 to see this a little better. Okay? I'm going to have 4 over 1 times 7/2 x. We'll write our other one here. It's also going to be 1/4 times 4 over 1. Okay? So let's look at both of these multiplications that we've just made here. Okay? Do you remember how we multiply fractions? What is 4 times 7? 4 times 7 is 28, okay? And 28 is going to be divided by 1 times 2. 1 times 2 is 2, okay? What's 28 divided by 2? Or half of 28 is 14. Okay, so here we're going to say y equals 14x. So we have a whole number now. And over here we have 1/4 times 4 over 1. Okay? What is 1 times 4? It's 4 over 4 times 1 is 4. 4 over 4 is same as saying 1. Okay? So we could just say plus 1. So now I have y equals 14x plus 1, and we've finished step 1. We've gotten rid of our fractions. Now we need to get all of the numbers alone on one side of the equation. Which of these 3 parts is just a number? Good, my positive 1. So I need to move 14x. If my 14x is positive here, I need to do the opposite to get to the other side. So I'm going to subtract 14x from both sides. Okay, my new equation then is going to be negative 14x plus y, because my y is positive, equals 1. That's it. That's all I have to do.